Welcome to Exquisite Academy. In this video, we'll be talking about equations of a straight line. Now, the first thing you must know is you must have to know what a straight line is before you start talking about the equations. Now, a straight line is a line of which the variable, the unknown variable, the power of that variable is 1. Now, if we have y equals to 4x plus 3, and we have 2y plus 3 equals to 7x, and we have x raised to power 4 plus 1 equals to 3, and we have x raised to power 1 over 2 plus 1 equals to 4. Now, this is a straight line because the unknown variable here, the power of that variable y is 1, and the power of this variable x is 1. So this is a straight line. The power of this variable here, y, is also 1. The power of this variable here is also 1. So it is also a straight line. The power of this variable here is 4. So we do not need to stress ourselves. It is not a straight line, it is a curve. The power of this variable here is 1 over 2. It is not a straight line, it's a curve. So if there are equations, if you can manipulate any equation such that the power of x and y becomes 1, it is also a straight line, because ordinarily here the power of x is 1, but you cannot say the power of y is 1 here. You have to use binomial expansion to expand it, and you'll be seeing different powers of y. Not until you take this one here before you can conclude that the power of y is 1. So for this case, once you can manipulate this to this, it is also a straight line. So this is a straight line. So when you plot any graph of this, you will find that there is a straight line. If you plot graph of this, y equals y against x, you find that it's a straight line. But when you plot this, you see that is a curve. When you plot this, you see that is a curve. So there are 4 equations of a straight line. There are 4 equations of a straight line which comes in different form depending on what you are given in any problem. Now let's come over here. There's something we call the gradient of a line, of a straight line. There's something we call gradient. Now this is a straight line passing through this point x1, y1, x2, y2. This is a straight line passing through this point. Now, this is the point, and this is the point. Because this is a straight line, for every x I put here, there is a corresponding y in this line. So if I choose any point here, there must be a corresponding y. But first of all, let's talk about the gradient of this line. This is what we call the gradient of this line. The gradient of this line is actually the change in the y-axis, which we did in our first video, that our change in y is y2 minus y1, and our change in x is x2 minus x1. So the gradient of a straight line is the change in the y-axis all over the change in the x-axis. This is what we normally call the slope. So even in a curve, when you want to find the gradient of a curve at a particular point, you will still draw a straight line that passes through that point. Then you find the gradient of that straight line. So we said the gradient in this course, we call the gradient m. We use the alphabet m to represent the gradient of a straight line. The gradient of a straight line is change in y over change in x, which is this. So we can say the gradient of this straight line is y2 minus y1 all over x2 minus x1. This is not the equation of the straight line yet. This is not the equation of the straight line. Now, if I know this point y2, and I do not know this point, and I know this point x2, but I do not know y and x, y1 and x1, I will subject y1 and x1 to be variables. I will subject y1 and x1 to be variables because I know that for every x I choose, I must get a y. For every y I choose, I must get an x, which will pass through this point. So this becomes the first equation of the straight line, which is this y2 minus y all over x2 minus x. So this is the first equation of a straight line. This is the first equation of a straight line. Since I know that for every y and x, it must pass through, it must touch this line somewhere. So this is what we call the first equation of a straight line, where we know y2 and we know one of the coordinates, x2, and we know this coordinate, and we know the gradient of the line. So once you are given the gradient of a line, and you are given one point that line passes through, you can get the equation of that line. So the second equation of the line, since we know that m is normally y2 minus y1 all over x2 minus x1. Now if we're not given the gradient, of this straight line now, but they now gave us two coordinates. From these two coordinates, we can get the gradient, which is this. Now if we get the gradient, we can now equate it back to this to get the equation of the line. So this will be the second form of equations of a straight line. The second form becomes y2 minus y1 all over x2 minus x1 equal to y2 minus y all over x2 minus y. So this is the second form of the equation of a straight line. This is the second form. The first form is when you are given the gradient of the line and you are given just one point that the line passes through. The second form is when you are not given the gradient of the line, but you are given two coordinates, 2 points that the line passes through, such that you first of all use those 2 points to get the gradient of the line and you equate it to this. Now there's something they usually do. Now sometimes they might not give you the gradient of the line and they might not give you two coordinates. Now if you observe, this line makes an angle with the horizontal axis. Let's call that angle theta. Now, do you know that tan theta, from our trigonometric ratio, tan theta is opposite over adjacent. So our tan theta is changing y, opposite, all over changing x. Now it therefore means that our gradient is tan theta. So if you are not giving the gradient and you are giving the angle it forms with the x-axis, not the y-axis, if you are given the angle it forms with the x-axis, you can get the gradient of the line. So the tangent of that is the gradient of the line. Sometimes they will give you two coordinates and they will ask you to look for the angle it forms with the horizontal axis. Now if you know the gradient of the line, the inverse of the tangent of your values will give you the angle it forms with the horizontal axis. So that's the first two forms of a straight line. Now let's talk about the third form. Let's talk about the third form. In doing so, we'll talk about intercept. Intercept. Now the intercept is the point where the line touches the x or the y axis. That's what we call the intercept. Now if this intercept, it touches the x axis at this point, so this will be the intercept on the x axis, and this straight line touches the y axis at this point, so this point becomes the intercept on the y axis. Now the peculiar thing about intercept is that at the intercept on x axis, the value of y is 0, and at the intercept of y axis, the value of our x is 0. Now if we come here, now if x is 0, we will get the intercept of y, and if y is 0, we'll get the intercept of x. So let's say x is 0. So the intercept of y, let's call that intercept of y c. So the gradient m will be y2 minus the intercept on y axis, which is c, all over x2 minus 0. So anything, if you remove 0 from anything, it makes no difference. So if I multiply this, now let me take this as a variable. Let me take this x2 as a variable and take this y2 as a variable. So if I take it as a variable, if I multiply this with this, I will have mx is equal to y minus c. If I take this one to this side, I will have mx plus c is equals to y. So the second form of the equation of a straight line is y equals to mx plus c. This is the commonest form of the equation of a straight line, where you are given the gradient of the line and you are giving the intercept on the y-axis, not on the x-axis. You are giving the intercept on the x-axis, on the y-axis, and you are giving the gradient of the line. You can form the equation of that straight line. This is the third form of the equation of a straight line. Now let's talk about the last form of the equation of a straight line. Then in our next video, we'll solve some few problems on equations of a straight line. Then we'll move over to perpendicular lines. Since we have agreed that the equation of a straight line can be written as this, where C is the intercept on the y-axis and M is the gradient. Now we said if y is 0, the x you get will be the intercept on the x-axis. So if y is 0, whatever we'll get for x will be the intercept. So 0 is equals to mx plus c. Mx is equals to minus c, and x is equals to minus c over m. X is minus c over m. So the intercept of, if you know the gradient of a line, of a straight line, and you know the intercept on the y-axis, when you do minus c over m, you get the intercept on the x-axis. But that's not what we are trying to portray here. I'm using this to establish a fact before we start talking about the fourth form of a straight line. Now, if I take this mx to this side, I will have minus mx plus y. Okay, let me take intercept on x-axis is minus c over m. Then the intercept on y-axis is c. Let me keep this one here because it will be very useful. If I take this mx to this side, I will have minus mx plus y is equal to c. Now, if I also divide through by c, I will have minus mx over c plus y over c is equal to 1. Now, because I know that there's something over c, over y, and there's nothing multiplying y, it's just 1 is multiplying y, I would love to manipulate this expression to be in this form, x over something. It should not be something times x over c. I want it to be in this form. So I can easily say minus m over c is the same thing as c over m minus c over m raised to power minus 1, which is the same thing. So if I change this part here, I will have c minus c over m raised to power minus 1 times x plus y over c. And you know one rule of indices, when you have a negative power, if you want to change it to positive, you will take it downward. You have minus c over m. So here I can write it as x over minus c over m plus y over c equals 1. Now, do you remember that minus c over m is the intercept on x-axis and c is the intercept on y-axis? Now, to get the equation of a straight line, when you know the intercept on the x-axis and you know the intercept on the y-axis, x over intercept on x-axis plus y over intercept on y-axis will always give you 1. X over intercept on x-axis plus y over intercept of y-axis will always give you 1. So if I call this A and I call this B, I can rewrite the equation as x over A plus y over B equals 1. So this will become the fourth equation of a straight line, where A is the intercept on x-axis and B is the intercept on the y-axis. So that will be all for this video. Please do not forget, like and subscribe to Exquisite Academy. More videos will pop up soon. Thanks for watching.